Okay, you're going to take a lot of notes today, a lot of vocabulary today. So page 126, parallel lines, skew lines, and perpendicular lines. Let's begin with parallel lines. Okay. What makes two lines parallel? Should we just start with that?
Never intersect.
What was that?
They never intersect.
They never intersect. They stay the same distance apart all the time. Okay. So let me ask you then. I've got a blue and a red line here. Can you see them? Okay. Can you kind of see the way they're going? All right. Are they intersecting? They're not intersecting, are they? The blue one's way down here, red one up above. Imagine that they're lines, they're traveling forever, right? Can you see that? Like that? Okay. They're not intersecting. Are they parallel then? No, you know they're not parallel, don't you? Okay. So there's more to it than just they don't intersect. Now, if we say they're equidistant, or they are always the same distance apart, what we mean is if we put a line between them or a segment between them that's perpendicular to both of them, then that segment would always be the same length. And that's not going to happen in this case, is it? So these don't kind of follow that. So parallel lines, first of all, they have to be what we call planar. Planar simply means that they are in the same plane. All right? So parallel lines are lines that are planar and they are equidistant. Always equidistant. They never intersect. Okay? So if they're in the same plane and they do not intersect, then they are parallel lines. Not just they don't intersect. And when we talk about that they're equidistant, if we were to measure the distance between the two of them, so this segment right here, this segment right here, this segment right here, those segments would all be congruent, wouldn't they? That distance between the two lines always remains equal. And this would not be a distance between the two lines, would it? Why not? Yeah, it's not the shortest distance. That's exactly right. When we talk about the distance between two things in geometry, in mathematics, we always mean the shortest distance. And the shortest distance is this perpendicular segment. Okay? So that's the deal with parallel lines. These other two, remember these guys? Okay? These are not planar, are they? Now they don't intersect, so we call them skew lines. I don't know if you've heard of those before. Skew lines are two lines that do not intersect, but they are not in the same plane, so they're not parallel. I think if someone were to say something like, I think your point of view on that subject is skewed, what they're saying is that you're looking here and they're looking there. Okay? So you're not having the same view of something. Okay, the last one is perpendicular lines. Perpendicular lines, what do we know about them? They intersect how? Yeah, they intersect at a right angle. Now, do they have to be in the same plane? Or anytime I draw two lines that intersect at a right angle, is there a plane that contains both of them? There is. And we can show that a little bit better if I draw a cube here for you. So let me... So I'm going to draw this as if it were three-dimensional. And this is a cube, so this is a right angle right here. These two are intersecting at a right angle. These two are intersecting at a right angle. These two intersect at a right angle. Everything is intersecting. Those are all perpendicular lines, aren't they? And if you choose any two of them, is there a plane that contains both of them? So we can just choose two at random. This one back here, this one back here. They're perpendicular, aren't they? Is there a plane that contains them? What is that plane? GHE. Is that it? So we're talking about this point, that point. Does that describe the plane that contains our two red lines? How about GFE? How about GEF? Okay. All right, let's look for some parallel lines. We just talked about GF. That segment is perpendicular to FE. GF, what is it parallel to? HE? And is it also parallel to something else? BA? Are all three of those lines parallel? Are all three of them parallel at the same time? That's kind of a weird thought, isn't it? So those two are parallel, and these two are parallel. Even, you know what? Even these two are parallel. Is that weird? What do you guys think about that? Are those two parallel? Are they in the same plane? Or is there a single plane that contains both of them? Yeah, it's not drawn. Okay, it's not drawn as part of my cube, but it's there, isn't it? Can you guys see the plane that... Right here, isn't it? Okay, it's there. So if we can name three non-collinear points, A, B, H, that's a plane, isn't it? So those two are parallel. And then GF is parallel to AB as well. But all three of them at once are not parallel, are they? All three of them aren't in the same plane. Kind of an odd situation, isn't it? Michael, you had a question, I ignored you. What is it?
I was just going to ask if C and D was also parallel to D and F.
Yeah, CD, I'd say it's parallel to HE, and it's parallel to GF, and it's parallel to BA. Yeah. But again, all four of them, not. Huh. Hey, poke Chase and be like, hey, are you awake? You with us? This is word day, getting it all written down. So we've got parallel, we got perpendicular, and we have skew lines, right? We have perpendicular lines here, we have parallel lines here. Do we have any skew lines here?
Yeah.
Here, I'll name one. I'll just name a line, BC. I'm pretty sure there has to be a line in here somewhere that's skew to it.
AH.
AH?
Yeah.
Well, that's a weird one to choose. That one actually goes diagonal through there. You guys okay with that?
Also H.
The diagonal? What about HE? Different plane, doesn't intersect. There's a lot of them, aren't there? Okay. So we have skew lines here as well. Ooh. Let's look at page 127. Right at the top of the page. Any problem looking at that little figure and saying, which ones are parallel? Lines what? N and L. Which ones are perpendicular? Line K and either N or L. It's actually perpendicular to both, isn't it? Is there a skew line there? No, those are all in the same plane, aren't they? Okay, all right, simple enough. So there's a parallel postulate. What is postulate again? Okay, a postulate, something so simple that we all go, well, yeah, it's got to be that way, right? So if I have a line, we'll call it line L because we have no imagination, and we have point P right here. The parallel postulate says that if there's a line and a point not on the line, then there's exactly one line through the point parallel to the given line. That's confusing. Let's say it a little bit differently. See this line right here? See that point right there? There's only one line that can go through point P and be parallel to line L. That's it. Only one. You agree? Okay. The perpendicular postulate says there is only one line that can go through point P that is not on line L and be perpendicular to line L. So we have a line, we have a point that's not on the line. There's only one line that can go through that point and be perpendicular to line L. Should we find it? We can do it by construction. Take a look at this one. Remember, go down here a little bit, make our smiley face. Doesn't matter how our protractor, or sorry, our compass is adjusted, just as long as we just kind of go down through and come up on the other side. And then we just start at these 2 points, these 2 intersections. Now I can adjust my compass at this point, it doesn't matter where I have it. And I just make an arc, I cut an arc, but then when I come over to this point, I need to leave my compass adjusted exactly the same, and I need to make that same arc. So if this were point A and point B and B are the same distance from point C. Those are equidistant. And then if I draw this segment, it's perpendicular. This is also the midpoint of AB, isn't it? Right? Now, could there be another line that could go from point P through line L and still be perpendicular? Like, could we have another line over here, like another segment? Could that one also be perpendicular to line L? Is it possible? Are you sure? How are you sure? Take a look at this triangle right here. What kind of triangle is that? A what? A right triangle. PM, from P to M, that segment right there, that's a leg of the right triangle, isn't it? And P, I'll call it X, PX. Which side of the right triangle is that? Say it louder. The hypotenuse. In any right triangle, which is the longest side? The hypotenuse. The hypotenuse is always longer than one of the legs, isn't it? Either of the legs. Okay, so it doesn't matter where I draw another segment. That segment is the hypotenuse of a right triangle, and this is the leg, isn't it? So that's always going to be shorter. Okay? That's the perpendicular postulate. The parallel postulate and the perpendicular postulate. Okay. Now, this is the word. This is word day. Okay? We're going to talk about transversals. You guys have heard of the Transcontinental Railroad, haven't you? Okay. Why is it called the Transcontinental Railroad? It transverses the entire continent, doesn't it? Okay. So it goes all the way across. So if I have a couple of lines, and I want you to notice that I'm not being careful about it, and these are not meant to be parallel. A line that passes through both of them, it transverses them. Okay? So this blue line is called the transversal. That's the transversal. Notice it's pointing at its name. So we got to know what a transversal is. That's our first word. Then we have to know corresponding angles. Now, there's a reason why we're going to talk about corresponding angles and the other three that we're going to talk about today. But for today, you just have to learn the words and learn what they mean, where they are, how to find them. And then tomorrow we'll talk about why. Okay? So corresponding angles, I'm going to go angle 1 right here and angle 5 right there. Why do you suppose I say that those two are corresponding angles? Can you describe it for me? Yeah, you could look at it that way. I'm gonna even make it simpler for you. As I look at the intersection with the transversal, do you see how they're both kind of top left? See what I'm talking about? They're kind of in the same location on the transversal right here, on the intersection. Okay, so they correspond. So let's say angle 2 and, well, let me just label all these 4, 5, 6, 7. Angle 2 and angle what? Angle 6. So we have angle 1, it corresponds to angle 5, angle 2 corresponds to angle 6, angle 8, what does it correspond to? Angle 4, you're catching on. And there's one more, angle 3, what does it correspond to? Yeah, angle 7. So that's the deal with corresponding angles. They're just the angle kind of in the same spot on the intersection. Okay? They correspond. Corresponding location, let's say. Let's see, the next one we better talk about is alternate interior angles. And I'm going to show you one right now. Angle 4, angle 6. Let's start off with the interior part. Do you see why they're interior angles? They're on the inside here, aren't they? Okay, they're on the inside. And they're not corresponding, they're not in the same location, they're actually alternate from one another, aren't they? So what's the other pair that are alternate interior angles? Yeah, 5 and 3. So we've got 4 and 6, we got 5 and 3. Okay, so now alternate exterior. Yeah, I already hear you guys saying it. Angle 1 and angle 7. Okay, angle 2 and angle, which one?
8.
All right. So those are the alternate exterior. So we have corresponding, we have alternate interior, and we have alternate exterior. Now there's one more angle relationship that we need to know. This one's called consecutive interior angles. So this would be 4 and 5 consecutive interior angles, and 3 and 6. Now, some of you might be saying, what about 4 and 3? They're interior, and they're right next to each other. So, are they consecutive interior angles? No, they're not. You'll see why when we start talking about all the relationship stuff here. But no, they have to be on a different intersection in order to be consecutive interior angles. So just 4 and 5 and 3 and 6. Okay, look at the bottom of page 128. See number 3? What's the relationship there with 1 and 5? What do you say? Corresponding. They're in the same location, aren't they? In this case, we could say they're both top leftish, right? Okay? All right, good enough. Number 4, what's the deal there? Alternate exterior. Alternate exterior, that's correct. And then what about number 5? Yeah, consecutive interior angles. I will show you one that can drive you a little crazy that I think you'll see today. This can drive you nuts if I start talking about angle 3 and angle 10. What's the deal there? Okay. Well, the best thing to do is just look at the two intersections at angle 3 and angle 10. Just ignore that one right there. That has nothing to do with it. You can only look at two intersections at the time. So we have our two lines. This is our transversal. What's the deal with angle 3 and angle 10? Yeah, they're corresponding. How about 5 and 10? Just cover that one up. Okay, are they both interior? Are they both exterior? Do they correspond? They don't correspond. They're not both interior. They're not both exterior. They can't be consecutive interior. What is the deal with 5 and 10? Well, there might be some relationship, but is it one of the 4 relationships we talked about? No. They don't correspond. Okay? They're not both interior and they're not both exterior, so nothing there. How about 5 and 11?
I don't understand why they're not both exterior.
Ooh, that's a good question. Well, let me turn this a little bit here. So if I look at my two lines with my transversal, I would say 8, 7, 9, and 10 are interior. You guys agree with that? And then 5 and 6 and 12 and 11 are exterior. Now 10's a little weird. Look, if you look at it this way, now 10 is exterior angle, isn't it? So on this transversal, 10 and 11, 2 and 1 are exterior angles, aren't they? But if you look at it over here, now 10's on the interior of the intersection, isn't it? A little bit weird. You got that? So see why I'm covering one side up and ignoring that part? Okay. Very good. So today's all about the words. Parallel lines, skew lines, perpendicular lines, transversal, consecutive angles, corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. Now, if you do the homework right now, hopefully these will get in your brain and stay there. And don't worry, they're not going away. We're going to be talking about them all year. There you go. Let's do it.